Mr. Johnson here. Hope you are doing well. Thank you for those of you who've been doing your Khan Academy stuff and getting on Zern. It's really awesome to see a lot of you really still holding yourself accountable even at home in this weird time. So I'm going to start kind of filming my PowerPoints. I'm going to be uploading the problem set so you guys can start working on those. So this is our first lesson. Welcome to volume. All right. I know some of you, especially those of you who have been in tutoring, kind of have a crash course on volume a little bit. But for the rest of you, don't worry, we're going to kind of dive in right now. So lesson 1, we're going to be exploring volume by building with and counting unit cubes. So we are first going to be building a solid from cubes, and I know this is kind of tough because you guys don't have cubes at home, so just kind of bear with me on this first slide and just pay attention and listen, kind of do the stuff in your head. So we're going to shade a square on your centimeter grid with an area of 4 square units. So first I would just shade those 4 squares in, and then I would then build a foundation, which means I would take 4 cubes and I'm going to place them directly on top of those squares to have kind of a foundation. This is kind of like building a house. Think of like a bottom layer, that foundation, kind of that basement is the bottom layer of a house. So those are going to be our first 4 cubes. So if this is the bottom layer, these 4 are the 4 cubes are the ground layer of a building. If we put a second floor on it, we put another cubes on top of them, how many cubes are there going to be now? If we have that bottom layer of 4, then we add another layer of 4 on top, how many cubes are there going to be now? There would be 8 cubes because we would be stacking another layer of 4 on top. 4 plus 4 is 8, right? Now, did we change the ground floor? Why or why not? Obviously, you can't talk to anyone, so just think about it. Did we change anything about the ground floor? No, we just built on top of it. So the second layer of cubes doesn't make it take up more space on the ground. We're building up like a house. A house just goes straight up. We're not building out. So that basement, that foundation, the bottom layer, it's not getting any wider, but our building is getting taller. Our structure is getting taller. Now, if we put another layer of 4 on top of that, think about what your total number of cubes would be then. So we already knew that we had 8 cubes. If we put another 4 on top of that, that would be 3 layers of 4 cubes, and we could think of it as 4 plus 4 plus 4, or you could think of it as 3 times 4, which would get us a total of 12 cubes, which means that this structure would have a volume of 12 cubic units. So for volume, we'll be using cubic units, all right? Okay, so we know that volume equals length times width times height. It is building off area. We know that area is just length times width. So to get volume, you're taking the area and you are then multiplying that by the height of your structure too. All right, so now we are on the problem set. We're going to look at 1A. Now for 1A, this is just 1 cube. So the volume of this 1 cube would be 1 centimeter cubed. And that exponent with 3 means cubed. You could also write it out in words as 1 cubic centimeter. Now an explanation for this is I just counted the 1 cube. There's 1 cube, so I know the volume of this structure is going to be 1 centimeter cubed. Now think about this one. How many cubes do we have right there? How many cubes are building this structure? There are 5, so what would be the volume of this structure? Just like with our last one, if we're going from 1 cube, now we have 5, it's going to be the same units, centimeters cubed. Now it's going to be 5 centimeters cubed. And our explanation, very similar to our last one, is going to be very similar to this one. We just added that bottom layer of 3 cubes, and then we counted the 2 more on top. We added 3 plus 2, we know is 5. To get a total of 5 centimeters cubed. See, going to kind of follow that same strategy, figuring out how many we have on the bottom layer, in the middle layer, and the top layer, and then combining them all together. Okay? You can also see now that we're getting the length and the height. We have 3 across and 3 up. So we know that 3 rows of 3 is going to get us a total of 9. And there is also 9 cubes in total, so you would have 9 cubic centimeters or 9 centimeters cubed. For this one, we are going to multiply. We had 3 layers, and each layer had 3 cubes in them, so we multiplied 3 layers times 3 cubes to get us 9 cubic centimeters. Now D gets a little bit trickier, all right, because there are some cubes that are kind of hidden out of the way. So take a second and see if you can figure out how many cubes are in total making up the structure D. There are 9. And now some of them are hidden. You can see kind of a little triangle of that back bottom one, all right? Some of them are going to try and trick you, and some of these cubes you're not going to be able to see, so it's a little tougher to get an idea on what the volume is going to be. So for this one, we counted the front layer and then carefully counted the back. So for this one, you more or less have to just count how many cubes there are in total to figure out what your total volume is, how many cubic centimeters there are going to be. Now for E, this one's a little bit easier. You can actually use the volume formula. We can find out the length, the width, and the height. So if you can figure that out right now, try and figure out what the volume is by multiplying those 3 numbers. So we have a length of 3, a width of 2. 3 times 2 is 6. And then we have a height of 2. 6 times 2 is 12. So structure E is going to have a volume of 12 cubic centimeters. And just like I had explained, we counted the end layer. The end layer there is 4 cubes, and then we multiplied it by 3. So there's different ways we can go about it. In this one, the explanation is that they took that layer all the way to the right. That was a mix of the length and the width and the height of 4 cubes, and they saw they had 3 layers of that, and 4 times 3 is 12. Now for F, the same thing. We can use our volumes formula and find our length, which is 5, our width, which is 2, and our height, which is 2, and multiply them. 5 times 2 is 10. 10 times 2 is 20. Now you can also see that each layer has 4 cubes in it, and if there are 5 layers, 4 times 5 would get you that same volume of 20. We can also count the bottom layer, which is going to be 10. And if we have 2 layers of 10, 10 times 2 is 20. So this is our first page of our problem set. So you guys should be able to fill that all out. Now we are going to go on to representing solids on isometric dot paper. Now this one is going to be a little tricky. You're going to have to just try and draw it with using the mouse on your computer as I go. So we are going to build some other structures, but we want to draw what we built. So we're going to learn how to use these dots. They're called isometric dots. And we're going to use this paper over here to draw our structures. So we're going to start by drawing 1 cube. So I'm going to go ahead and connect 4 dots to make a parallelogram. And this is going to be one square face of the cube viewed at an angle. So you can see I'm going through and drawing 4 lines to make a parallelogram. And this is now, like I said, is representing one square face of the cube. Once you have that done, we're going to draw 3 straight segments, which are lines. We're going to draw them to the right from the 2 vertices on the top and the one on the bottom right. So we're going to be drawing lines going back from 3 of these dots. So just follow along if that was a little confusing. I have 1, 2, and 3. So you can see that our cube, we're starting to find our structures becoming a 3-dimensional cube. Now we're going to draw 2 line segments to represent the missing edges. So you can see that there are a couple parts of our cube that have not been connected. We're going to go ahead and connect them now. Now you see that we have a full cube. Now what we're going to do is we're going to put 2 cubes right next to each other. So off of this cube, we're going to build another cube. So I drew that line segment branching off to the left to make another parallelogram. And then I'm going to draw my line segments heading back Now for this one, I didn't need to draw as many lines because we are connecting it with our first original cube. So now we have two cubes that are right next to each other. So this is basically the beginning of volume, and you can use this PowerPoint to help you out with working on your problem set. If you need anything, I will post an exemplary model on Schoology that you guys can refer to check. Try the problem set on your own. And I know it's a little tough, but do the best you can with writing with the mouse. I know that's not the most fun, but I think you guys will get used to it. If you need anything else, please reach out through Google Classroom, email me, and I hope you guys do well with this. All right? Talk to you soon.